Hello, and welcome back to another episode of Oasys Top Tips. Did you know that in Oasys PRIMER you can plot the constraints in your model to easily check that your boundary conditions are set up correctly? So I have a model open here. This is the crush tube example that we looked at last time, and I've sketched the SPC constraints here. And at first glance, it might look like they all have the same constraints applied to them. However, a couple of things give them away that that isn't the case. So firstly, when I hover over the constraints, they highlight separately, indicating that they're actually two different SPCs defined. And then if I zoom in a bit to make it clearer, you'll be able to see that the constraint here has boxes around the end. However, here it just has crosses. So in Oasys PRIMER, the crosses represent a translational constraint, and the boxes represent a rotational constraint. So what this is telling us here is that there's a translational Z constraint, Y constraint, and no X constraint, and that's because there's no cross through the middle. However, that's actually quite hard to see when you've got it plotted like this, especially when you're zoomed out or in a model which has lots of constraints. It can be a bit confusing and hard to tell what's going on. So Primer actually has a really useful tool to help you plot these constraints. Of course, you can open up the keyword and investigate them, and you would be able to see that they're different here. You could obviously sort them by the different values in the columns as well, to find those that are ones and zeros. But if we go to the node plotting functionality here and then click on the drop down, we can see that we have the options of plotting initial velocities for translation and rotation, as well as nodal masses. And then here are the things of interest. We've got SPC, translational, and rotational. So when we click on SPC translational, and then we node plot that, we'll immediately see that we have different colored blobs appear. So using the key on the right-hand side, we can see that the black blobs represent an XYZ global constraint because they're blobs. If they were local, we would see a triangle there. And then the cyan colored blobs represent just a YZ constraint. So we can quite clearly see that this middle tube, the green one, has a different SPC constraint on it. Additionally, we are also shown that the rigid plates at the end have a constraint applied to them. And that's really handy because that wasn't shown when we were plotting the SPCs. But the reason for that is because the constraint on them is applied to the material. So if we quickly open up the material pane and then click on one of those plates to find the reference material, we can see that we have a constraint defined. So the 1 here just means that it's active and it's defined in the global axis. Otherwise, -1 is the local and 0 just tells us that it's turned off or it's not constrained. Then these two numbers here represent first the translational and then the rotational constraints. Using the drop down, we can quite clearly see that the Y and the Z displacements are constrained, and that corresponds to the cyan color we're seeing here. And then also the rotational constraints are X, Y, and Z. So if we just close that down and then switch this to rotational constraints, we'll be able to see those black blobs at the rigid plates. And then we can also see that the rotational constraint is only on the x-axis at the end on the nodes of the green crush tube. So in order to fix that, we can simply go to the SPC card and then open up the keyword. And a little tip here is if you want to basically propagate a value from a cell in a column to all the other columns that are selected, you simply click on a cell that has the value you want to be propagated and then press enter, and you can see that it sort of fills down or propagates all of the other cells selected. In this case, it's just 2 cells selected, so I could have just typed it in, but it's a quite handy tip to know if you didn't know that already. Then we update, and we can see that the rotational constraints have updated to be consistent, and then coming back to the translational constraints, those are also consistent. So that's just been a very quick top tip on plotting constraints in Oasys PRIMER. I hope you found that useful, and I look forward to you joining me for the next Oasys Top Tips.